Given a photoelectron spectroscopy plot, and this one's idealized. Real ones don't look this pretty. And it's asking us to identify what element it is and explain the location relative intensities of the three peaks that are shown here. Photoelectron spectroscopy, PES, is a very practical way to help us identify the structure of atoms. And so what we'll do is, using a similar concept as the photoelectric effect, so this one is going to be carbon. And so in carbon, it has these 6 electrons. Actually, this is going to help me explain why there are these peaks. Carbon's got 6 electrons in its neutral atom. The first orbital is going to be the 2 electrons going into the 1s orbital, and then the 2s orbital, and then the final 2 are going to be in the 2p orbitals, like that. What we can do is we can shine a light. Let's do it this way. We shine a light onto carbon, and if it doesn't have enough energy, if the frequency is low, none of these electrons are going to eject. But as we increase the energy of the light, and we have control over that, eventually these electrons are going to shoot out with some kind of kinetic energy, and we can measure that, and then using that information we can plot these intensity graphs. So you have a whole sample of carbon. The ones that are going to eject first are the ones that require the least amount of energy, which are these electrons in the 2p orbitals. All right, and then it's going to require a little more energy than that to eject these electrons in the 2s orbitals. And then if you increase the frequency, eventually X-rays will we can use X-rays to strip every electron off, and then this one even more energy, and then we can get all 6 electrons to eject. So that's what's going on here. That information is shown in this graph here. Now the convention is, as you go across the x-axis, we have decreasing binding energy. So the first electrons to be removed are going to be these ones over here. So you're going to have to look at the relative peaks, because that on the y-axis that tells you the number of electrons. Now the thing that makes this graph a bit tricky is all the peaks are the same size. So you'll just have to do some of these, and then you'll see, you'll get better at seeing the patterns here. So these represent the 2 electrons in the 2p orbitals. They're the easiest ones to remove. And then this peak is the same height, so that's also 2 electrons, but it's going to require a little more energy because they're more bound to the nucleus. But notice the gap is relatively close compared to this one. So that means these 2 peaks, electrons, are relatively closer in energy. So this is your 2s orbital and the 2 electrons in there. And this one requires more than 10 times the energy required to remove any of the second energy level electrons, and that makes sense because these represent the 2 electrons, the core electrons, in the 1s orbital.